Working with big amounts of data in Node.js means working with streams. A lot of people find it hard to understand and work with streams, and there are a lot of Node packages out there with the sole purpose of making working with streams easier. However, I'm going to focus on the native Node.js Stream API here. Streams, most importantly, give you the power of composability in your code. Just like you can compose powerful Linux commands by piping other smaller commands, you can do exactly the same in Node with streams. Many of the built-in modules in Node implement the streaming interface. This list has some examples for readable and writable streams. Some of these items are both readable and writable streams, and you can notice how the items are related. So while an HTTP response is a readable stream on the client, it's a writable stream on the server, because basically one object generates the data and the other object consumes it. Note also how the stdin, out, and error streams are the inverse type when it comes to child processes, which we'll talk about in the next module. Let's start by defining streams. Actually, pause the video and try to write down your own definition of streams. Streams are simply collections of data, just like arrays or strings, with the difference that they might not be available all at once, and they don't have to fit in memory, which makes them really powerful for working with large amounts of data or data that's coming from an external source, one chunk at a time. Let's jump right into an example to show you the difference streams can make in code when it comes to memory consumption. Let's create a simple web server that serves a really big text file. I've included a simple script for you to create a big file, and look what I used to do that, a writable stream. The FS module can be used to read from and write to files using a stream interface. Here, we're writing to this big file through a writable stream, and we're just writing 1 million lines with a loop using the .write method. Then we use the .end method when we're done. Running this script generates a file that's about 400 megabytes. So now we'll serve this file in a simple HTTP server using the read file method and writing the response inside its callback. We've done this before. Let me run this script, and I'll monitor the memory usage here using the Mac Activity Monitor. On Windows, you can use the Task Manager for that. Here's our node process using 8.9 megabyte of memory. That's a normal number. And when a client asks for the big file through our web server, the server's memory usage immediately jumped to over 400 megabyte of memory. That's because our code basically buffered the whole big file in memory before it wrote it out. This is very inefficient. Luckily, we don't have to do that in Node. The response object is also a writable stream. Remember how we streamed data with timers when we were talking about the HTTP server? And we used .write and .end on this response object, the same methods we just used to create the big file with the stream. Since this response is a writable stream, if we have the big file as a readable stream, we can simply pipe one into the other and avoid filling up the memory. The FS module can give us a readable stream for any file using this createReadStream method. And then we simply pipe this readable stream into the response writable stream. Not only is this code a more elegant version of what we had before, but it's also a much better way to deal with this data. Let me show you. We'll run the server, monitor the memory, which starts low as expected. And now when a client asks for that big file that we're serving, we stream it, one chunk at a time, which means we don't buffer in memory at all. Look at the memory usage. It grew by about 25 megabytes, and that's it. In fact, let's push this example into the limits. I'll regenerate this big file with 5 million lines instead of just 1 million, which should take the file to well over 2 gigabytes. And that's actually bigger than the default buffer limit in Node. So if we try to serve this file using readfile, we simply can't by default. But with the streaming version, there is no problem at all streaming 2 gigabytes of data to the requester. And best of all, the process memory usage is roughly the same.